Good morning, good afternoon, and good evening. Thank you so much for checking out our introduction video for software-defined networking. My name is Kyle Bisnet, and I am one of the SDN PMs on the software-defined networking team, and we sit inside of Core OS Engineering. Really excited to be here. Again, thank you for checking out our YouTube video. This is the first of many videos to come. We have another video lined up for software load balancing overview that Cindy's going to walk us through. We have another video for SDN multi-site, which is a new feature that we launched in HCI 23H2. Sam is actually going to be the one to walk us through that. And then myself and Anirban will be going through several other key features for SDN. This has been something that we've wanted to get off the ground for quite a bit, is making sure that you all, as our SDN community, and even those who may not be using SDN yet, have a great place to gain insights, knowledge, resources, tips from the product engineering group, tips from the field. We'll have a few field folks that will join in with us. And quick shout out to Flo Fox at the Hybrid Friends channel. So I actually did a video similar to this over on his channel. Recommend you go check them out, give them a like. They cover HCI all up. So everything and anything you can think of for HCI, I'm sure they have a video on it, including even hardware. Our videos are a little bit more streamlined to software-defined networking. Why customers would want to use it? Why do customers use it? What are some of the use cases? And really, how do you implement it, right? And why? Why would you implement it? We're really big about solving business outcomes, right? And SDN ties heavily into business outcomes, especially around the security story. So let's go ahead and get started. Now you'll see this isn't a YouTube video unless I start out with at least two quotes, right? And I want to go through these quotes with you before we actually dive into software-defined networking. So the first quote is 45% of intrusions contain a lateral movement event that can easily be solved with microsegmentation. The second quote is 96% of lateral movement attack behaviors do not trigger a corresponding alert on security controls. And this was put out in 2022. Now, it's rather surprising if you think about breaches that have happened across companies. And we have a saying at Microsoft, there's only two types of companies: those that have been breached and those that have not been breached yet. And it's really about ensuring that you have security controls in place to control the breach. It's hard to prevent a breach completely. We've seen that time and time again. So when we think about these quotes, think about that for a minute. 50% of intrusions contain a lateral movement that could have easily be solved with a 5-minute microsegmentation rule. 5 minutes. 5 minutes that you could apply that rule to a virtual network, 5 minutes that you could apply that rule to a VM network adapter, whether it's sitting on your SDN logical network, which is really a VLAN in your data center, or a VM that's sitting on a SDN virtual network, or i.e. an Azure virtual network. But then the second piece to that is 96% do not trigger an alert. So that's surprising. So, one of the things that we always talk about with SDN is it's kind of like our MVP factor, if you will, like the biggest, what we call the biggest bang for your buck, right, with SDN, is the ability to have security controls on your network. So you can apply network security groups on all of your VMs, on all of your SDN logical networks, all of your virtual networks. But then we take it a step further in that you now have full monitoring capabilities east and west on your HCI environments. You have audit logs, and then those audit logs can actually be uploaded to Azure so you can retain them for X amount of years, specifically when it comes to compliance, right? And ensuring that you're meeting compliance. So these are two big quotes I wanted to start off with. So now let's go ahead and get into what is software-defined networking. So software-defined networking is really about bringing Azure-inspired networking into your data center. And it's not about bringing the entire stack of Azure networking, but it's about bringing the pieces and the components that make most sense for edge deployments based on your feedback, your business outcomes, your requests. We are very keen on ensuring that we are gathering the right customer requirements and we are doing the right thing versus just doing the things right. And that's something that we as a PM team, as a dev team really focus in on, is making sure we're delivering the most amount of value for your networking experience on HCI and of course Windows Server when you're using virtualization on Windows Server. So let's take a look at the challenges that customers face, that folks like you face, and then how do we solve those? So I think it's no surprise that network management is complex. Back in my day, I started as a Cisco certified network associate, doing core networking, core routing, etc. And networks are complex. And what we've heard from customers is, hey Kyle, I've been using Azure for a while now. Why can I not have that type of network experience in my data center? If I think about, I want to create a load balancing rule. I want to have an advanced security appliance sitting in my virtual network. Those are core features that customers know and love now, especially with Azure, especially with cloud. So we need to be able to bring those down to the edge. And then on top of that, well, I have these workloads at the edge, but how do I protect them? Besides asking my network team to put access control lists on everything, it's almost impossible to protect all of your virtual machine workloads without SDN. Otherwise, you'd have to have a VLAN or a switch ACL for almost every virtual machine. It's simply not scalable and it's not easy. That's not easy to do. So that's something we always hear is, how do I now protect my workloads? The third thing is, we saw this a lot through COVID. We saw this a lot with supply chain issues, is the inability to easily automate a multi-vendor infrastructure. So yeah, you may have Stack HCI across your data center, but now you have to go buy another switch. And when you buy that switch, it may not have the same control plane that your other switches have because maybe you couldn't get those other switches. They were backordered and you needed to scale quickly for your applications. Well, that's where SDN really solves this issue, and we'll talk a bit about that in the next slide, but it's the same control plane regardless of where you're plugged into. Now, I say regardless, of course, we want to make sure that your switches are HCI compliant and they're HCI certified. But outside of that, if you're deploying network security groups, virtual networks, SDN logical networks, load balancing, gateways, like the slew of features that we offer, you don't have to worry about the gear that it's running on top of, right? Because that's technically all of your physical gear is your underlay, and SDN is an overlay technology, right? We just ride along the top of your physical infrastructure and we have our own control plane. And then last, but certainly not least, building, managing, and scaling network services is complex. If I take a traditional load balancer that I need to go rack and stack, in a rack, and then I need to provide power and cooling and maintenance contracts, etc. Network services are very complex. So if you can bring those into software and have them under a single partner, it makes life a lot easier. And your support calls also become a little bit easier, right? When something doesn't work, you essentially have a single line to call, and it's a little bit easier to diagnose as well. You're not having to go work with multiple partner teams, etc. So let's look at how we solve these in the next slide. So of course, table stakes is we want to drive agility and flexibility based on your business requirements. I mentioned in the beginning that we are very keen on making sure we bring the right features, the right outcome to the edge, right? And we do that based on what your business requirements are. For a long time now, right? The trend has shifted where it's not just deploying technology to deploy technology, but it's how does technology help your business run better? how do we ensure that your business exceeds its goals using technology? So there's a few ways that we do this, right? And when I talked about some of the challenges in the last picture, so we deliver the network as a dynamic, agile, and optimized resource. What do we mean when we say that? Well, it's a single control plane, and that control plane is accessible from PowerShell, from REST API. So if you're doing infrastructure as code, you can simply plumb everything into our APIs, and we'll take that and create the network resources for you. We also have Windows Admin Center as a GUI experience, a first-class GUI experience. And as we get further along into next year, you'll see certain things lighting up in the Azure portal for SDN. So we have quite a few ways that you can connect and communicate with the control plane. But then we have all these network appliances that plug into that control plane, like our Azure L4 load balancer, our gateways, our data center firewall. And that's really how we deliver this as an optimized resource. And again, I mentioned we don't care where you're plugged into, but as long as you have those requirements met from configuring software-defined networking, then the experience is ultimately the same day over day, right? So your day 100 operations will always be the same, regardless of where Stack HCI is actually plugged into. The second is tenant isolation and workload security. So if we take the zero trust model, or if we take an Azure model such as Cloud Adoption Framework or CAF, which you all may be very familiar with, we always have separate subnets, right? We always have a front end, a back end subnet. We may have a DMZ. So the benefit with SDN is you can stand up as many Azure virtual networks or SDN virtual networks as you wish. They all ride on top of the same physical VLAN in your data center, and they can do that because they're using something called VXLAN encapsulation. Now, on top of that, you can apply network security groups to all of your virtual machines, to all of your virtual networks, even your SDN logical networks. And SDN logical networks are really VLANs that are in your data center. So if we look at a typical customer on the journey with SDN, they usually start out with SDN logical networks because it's kind of business as usual, right? It's VLANs in your data center, but now you get to do things like apply network security groups and even have full audit and monitoring between those virtual machines. And then, on top of that, it's really seamless capacity expansion. Again, you stand up another HCI node, you plug it into a switch, you onboard that node to SDN, it gets all of the existing policies, virtual networks, LNets that you've already created, and then those virtual machines simply move over to that node and continue to work. So it's really easy to expand because we're using that single control plane. And last, but certainly not least, minimizing network complexity. No longer do you have to go ask your network team for another VLAN, for another application, and then ask them to ensure that there's switch ACLs there, etc. Again, the whole point of software-defined networking is to really bring Azure parity to the edge. And we want you to have the same consistent experience that you have today in Azure, without having to relearn all of your Azure networking experience that you've gained. So when we talk about Azure-inspired network infrastructure, and I already chatted about this a bit, we talked about the control plane. And in the middle, you'll see our control plane, and that's network controller. Network controller is not in the data path, right? There's no network traffic that's actually going through network controller for your workloads. It's simply a policy engine. The only interface on network controller is your management interface, and it will only send traffic out through your management and over your management VLAN. Now, when we look northbound, or what we would call our management plane, we have several options, right? We have PowerShell, we have REST API, we have Windows Admin Center with our SDN extensions that are constantly getting launched. And then, of course, we have Azure Arc, or the portal, and that's coming soon. You'll see a lot of features lighting up there. Now, when we look southbound, these are our data plane technologies, right? So these are all the things that are actually in the data path. One being our SDN gateways. So if you want to do a layer 3, a GRE, a site-to-site, you'll actually use our SDN gateways to do that. The second is, of course, all of the HCI hosts. So once you onboard Network Controller, you're using something called our Azure VFP, or Virtual Filtering Platform. And our Azure VFP has actually been taken direct from Azure. Of course, minimized a bit because compared to the Azure scale, HCI is pretty small. So you'll see Azure VFP light up on your vSwitch, which is our SDN vSwitch. And then that also includes the distributed HNV router. You'll gain network security groups right away. And when you input a network security group from, say, Windows Admin Center, network controller will then push that policy down using OVSDB to your HCI hosts. And then last, certainly not least, is our Azure L4 load balancer. So if you want to provide inbound or outbound NAT, if you want to provide load balancing for VM workloads, you'll end up using that Azure L4 load balancer. So let's take a look at the big picture. Let's take a look at all the features and we'll walk through some of those together. So this is the big picture, or what we also call Azure-Inspired Networking. Now you'll notice that we have this separated into 3 different groups, right? So we have a virtual network group, we have front-end and back-end connectivity. So when we talk about virtual networks, like I mentioned, cloud adoption framework, when we talk about Azure governance, you can have that same type of governance at the edge using software-defined networking, with being able to bring your own virtual network or just stand up your own Azure virtual network in your data center. Then you can have different subnets in that virtual network, and you can segment that with network security groups. We also have another feature called tag-based segmentation, which is very much like application security groups inside of Azure. So this is really great. You may be tired of having to deal with all the network constructs and the IPs and all the things that come with it. So now you can simply have a tag and you can say, hey, this tag is for infrastructure prod for SQL. And you can tie that tag to a network security group, and you can then tie that tag to a virtual machine or a virtual network. And you don't have to have any of the back-end network knowledge once it's configured. So especially for a junior admin that's coming in and you want to make sure that every VM has a network security group and is actually getting the right one, you can use tags to do that. Now that kind of falls into something called default network policies, which is essentially our No VM Left Behind Security Act. That's like what we refer to it internally. And the goal there is that right at the start of a VM build using Windows Admin Center, you can actually assign a network policy and you can choose to either block all traffic, allow traffic, or allow certain well-known ports such as RDP, SSH, WinRM, etc. And that's before the VM is even built. So you have a really great baseline. You've used a golden image. You've already applied network policies, and you've met those security requirements before the virtual machine is even built. Very similar again to what Azure provides today. Then we have user-defined routes or network virtual appliances. So I mentioned, maybe your security team has a request that we need to use a specific virtual appliance and the template is provided for Hyper-V. As long as the template supports Hyper-V, you can use that on SDN. You can use user-defined routes to route all of your virtual network traffic into that NVA, and then you can have that NVA make smart routing decisions on your behalf. Or you can have it doing filtering or scanning. That NVA could even be application controller, right? It could be a more advanced router, whatever it may be. As long as it works with Hyper-V, you can use that with SDN. Last but certainly not least is quality of service policies. So you can apply QoS policies, kind of for the noisy neighbor, if you will, or the SQL VM that's starving all of the resources, whatever it may be. Those QoS policies are available. So you now may be saying, well, I'm in a virtual network. How do I get out of a virtual network? I need a way to get outside of it, right? Because it's isolated. So you really have 2 paths. One is using our load balancer, which is our front-end access, or our gateways, which is the back-end access. So for the front-end access, you can do public IPs. Those public IPs are actually advertised up to your top rack switch in a /32 form using BGP. You also can use NAT inbound and outbound NAT. So NAT stands for Network Address Translation. Inbound NAT is a really good way at kind of providing an Azure Bastion service, if you will, where maybe you need a specific inbound NAT rule for somebody to get into that virtual network, and then they can do RDP from that jump box, but that jump box can be locked down with network security groups inside of the VNet. So again, it's a really good way of doing a form of Azure Bastion. Additionally, outbound NAT is a great way of providing internet access for a collection of virtual machines in your virtual network, using a single IP. So you're not taking up numerous IP resources on your physical network. You can use a single IP and then NAT all of that traffic for those virtual machines through it. And then last but certainly not least, again, is load balancing. So you may have two virtual machines that need load balancing, or in the case of AKS, we have full integration for AKS, which I'll have another video that's coming on that shortly. That's been GA for quite a while now. We do use our Azure L4 load balancers to provide load balancing to your AKS workloads. So you no longer have to use HA proxy or have an HA proxy VM deployed for everyone. Now, that's on the front end, and that's using our LBs. Now, when we look to the back end connectivity, we have three different types of gateway connections that you can provide from the virtual network. Oh, and by the way, you can use all three of them on a single virtual network. You're not limited. So IPsec, which is a really great way of providing secure site-to-site connectivity. So if I take a scenario like Parks and Rec, right? Say Parks and Rec, they have a central headquarters, but they need a branch / spoke location to every park for visitor IDs, etc. There's a really great way of connecting out to that appliance is by using a site-to-site and using an IPsec because, of course, it's secured. Most of those parks may have DSL connections. Maybe if you're lucky, they have Starlink, but you need to ensure that it's secure site-to-site connectivity. GRE Gateway is great for if you already have some type of MPLS WAN connection. You can simply use a GRE Gateway there. And then layer 3, which is actually what we see most used in SDN deployments, is simply a connection back to your physical data center. So you may have Azure Stack HCI with all of your virtual networks deployed, but then you'll have an L3 connection that terminates on a physical VLAN in your data center so that you can still access all of your corp resources as well. So you can have all your virtual network, VMs, services, etc., but now you can use that L3 gateway connection to talk back to everything that you've deployed that may be outside of HCI. L3 gateways are also a great way to provide DNS services, internet services to your virtual machines besides the front-end access that I spoke about for LB, for load balancing. And then last here is peering. So if I take Cloud Adoption Framework, and often what we recommend inside of Azure today, which is a hub and spoke method, you can do hub and spoke with software-defined networking. So you could have a hub virtual network that has some core resources sitting in it for HCI. That hub virtual network has an L3 connection out to your data center, and then you would simply peer spoke VNets to it, and it could share that L3 gateway connection. We have a lot of customers that actually use that today, and that works really well, especially for gateway connections. You can minimize that to a single gateway connection, depending on bandwidth and load, of course. Now, you may be saying, well, Kyle, you spoke to us a lot about Azure-Inspired Networking, but you also mentioned something about this being available to our existing networks that we use today, like our VLANs that we know and love. And that is true. So that brings us to what do we provide for traditional VLAN networks? Say you deploy network controller, just network controller. Well, there's a few things. First, now you have network security groups that you can place on your SDN logical networks. And again, those are just traditional VLANs, but we take the VLAN, we enter that into network controllers database, and now you can start plumbing network security groups. Additionally, you gain tag-based segmentation, you gain default network policies, and also quality of service policies. So again, it's a huge lift compared to what you had without network controller. And this is just deploying NC. Now, if you decide to deploy load balancers as well, then you do gain load balancing for your SDN logical networks. So, if you have 2 or 3 virtual machines sitting on a VLAN in your data center and you need to load balance those, you could then make use of our SLB MUX. Now, I've talked a lot about different components. We're going to do a deep dive on all the components and how are the components architected? Why are they architected that way? Look for a deep dive coming, and feel free to drop down in the comments if you definitely want to see that. We'll be sure to prioritize that. But when we look at scenarios, software-defined networking was really created from an a la carte approach, right? So if you need network controller, you'll gain X, Y, and Z. If you need load balancing, then you go deploy SLB and you gain X, Y, and Z. And you'll notice this chart that we're looking at. I'm not going to go through everything on the chart, but what we've done is we've tied in traditional scenarios that we see. What are the SDN requirements that you need? And then what are the network requirements that you have to actually go ask your network admin for? Once they're configured, they're set to go, and you essentially never have to really go back to them too much, unless it's for some type of a gateway connection. Like there's a few scenarios there. But if you're looking to deploy network services on traditional VLAN networks and you just need to secure your VLANs and have east-west monitoring and quality of service, the only thing you have to do is deploy network controller. Right now, the only network requirement we have is your management network, which chances are you've already deployed HCI, you already have a failover cluster. So it's just a matter of deploying network controller. And now you have a huge security boost to your HCI environment. Now, if you then said, Kyle, well, I have traditional VLAN networks, I want the security, but I also want to do load balancing. Well, then you would deploy network controller and our software load balancer. And you would have network requirements of a management network and a VIP network. Now, your VIP network is a range of addresses that can be used for load balancing. And basically, as VMs come online and a front-end IP or a public IP is assigned, we advertise that up through BGP, Border Gateway Protocol, to your top of rack switch so that the network then goes and informs other network services that this public IP is now available for use. And when you have an end user come in to consume the service that's running, it's then routed to the appropriate virtual machines on the back end, sitting on HCI. Now, if you want to deploy SDN virtual networks, you need network controller, of course, and you also need something called our provider network. So a few slides before, I talked about how we encapsulate all of the packets using VXLAN. And the way we do that is on a provider VLAN. So you give us a single VLAN, and then for every single piece of traffic, we encapsulate that with VXLAN. So if you have 2 virtual networks that are essentially having the same IP addresses, they actually never see each other because they're fully encapsulated. There's really 3 main networks. I'm going to fast forward all the way down to the bottom, which is, hey, I want to deploy network services on virtual networks. And this is where it's the entire deployment. So it's network controller, our software load balancers, and our SDN gateways. And that gives you the ability to run any of the SDN features. And it gives you those 3 network requirements. Again, the management network, which you already have because you've deployed HCI. The provider network, which is where all of our VXLAN encapsulation is going to take place, and then the VIP network, or the virtual IP network, which is where we're going to pull from there for our load balancing services. So it's really an a la carte approach that we tried to ensure was easy to use, and you could use certain components when you felt it was best for you. So I know this has been quite a bit of information for you all. I'm hoping that you guys and girls all gained a lot of value out of this. Please let us know in the comments, in the feedback section. Let us know what videos would be helpful for you. Like I mentioned, we have an SLB video that's coming up that Cindy's going to walk us through. So that'll give you more of some scenarios around load balancing. How does LB work? what's some of the architecture behind it, the fun stuff. And then Sam's going to be leading us up with a multi-site video, which is a new feature for HCI 23H2 that we're super excited about. Customers have been asking for this for quite a while. So again, like, subscribe, give us some feedback, and we hope you're enjoying these videos. And I'll be back with you all soon for another video. Until then, take care, and I hope you have a great rest of your 2023, and here's to 2024. Thanks all.